You know what? I goofed up. I didn't press record. 1 second. That's better. All right. Hello, everybody. Welcome back. So, I promised yesterday we're going to do the radio sound beacon. So today, I guess, time has come. Let's take a look here. So we got the radio detector. Right here. GLB. Well, hi. Good day. Good day indeed. How do I pronounce your username? Sisei? Sikei? Sisei? Radio detector. There we go. Okay, so... Damn, this thing looks awesome. So we need something. We need something to do with... Been waiting for your arrival. Hey, nice. I am here. Ready to get some work done. Okay, so we have this dictionary here. Points to the various locations. We got commissary, we got comms room, Isabel dorm. What do we have available? We have the room frequency ID. We have the radio frequency, so I suppose this is what we can match. Anytime we change one of these values... Hey! CK, got it. Iroh, good day. Whew. Man, we were planning to do a gaming session tomorrow, recording session to get some Artec content, but with this incessive cough, I don't know if I'll be able to make it, which is utterly the most disappointing thing because we only get to record like once every 3 months. Just getting more and more crowded over time. Yeah, it's nice, you know, getting some work done definitely pays off. So yeah, unfortunately, I don't know how I'm gonna be able to survive it, considering I can't even finish a sentence without coughing up a lung. That sucks. Cool. Right. So I think we have a way of testing this, right? Knob notches 746. I don't think we're using this anymore. Yeah, this is useless. Cool. We have knob rotations. And I suppose maybe we can also do knob rotation indices. Let's do 000. When we move our stuff, knob rotations, we have this thing called angle index. We can use it. Let's say, let's see, so knob index and then angle index. So we store it like this. And then we got to do the same thing here. And I suppose now we need to check, test it. Cool. So let's see what it tells me. I think there's 2 radios currently in the level. They're both going to be printing stuff. Oh. Come on. We also have a weird floating issue with the raycast detecting the ground. Okay. So. 1. And then this would be 7. 4. 0, 1, 2, 3, 4. Makes sense. And then this one, which is also 7. Cool. So we should be able to use that information to check what is the current radio, like what's the room that we're currently targeting. I guess we can do this. We need to detect when this changes. And I'm pretty sure knob rotations, or if we give it like a set get, I don't think it's going to react if we're changing it from within itself. Let's see. Knob changed. Knobs changed. Let's do a test. So func new value. Knobs changed. Need to make those numbers glow green. It's a good idea. I also need to make them larger. So yeah, so you see it doesn't really work this way. The set get will not execute within its own script when it's being executed within its own script. All right, fair enough. So let's do var old knob rotations. We're gonna make it equals to, I guess, an empty array. And this is where we're gonna verify that little feature if comparing two arrays is valid, even if there are two different array indices, like two instances, right? Two separate objects, not a reference of one another. I guess we'll need func process, because this is basic logic. If old indices is not the same as knob rotation indices, old indices will become a duplicate of knob rotation indices, and then print knobs changed. And I guess we can get rid of this guy. See how that works. Okay. There we go. Knobs changed. It's a one-time event. Beautiful. Okay, I guess this does work. So what we need to do now is we need to calculate. So let's do func calculate destination. Okay. So we know that we have this here, which is a map of all the destinations. Cool. What do we do with this then? It's a map of all the destinations. Radio relay. It's in a master node, so we need to find if this sequence of channels knob positions results in a destination. So for each entry in master node dot, and then what the hell is this? Bunker room IDs. Okay. There we go. So we're going to loop through all the IDs. What are we actually looping through then? Let me just place this up here. We're looping through these key value pairs. So each entry is going to be this, then this, then this, then this. So we do if we enter the bunker room IDs, we will use each entry as a key, which gives us access to this, or this, or this. So inside, we have a key value pair that I think it's not actually listed there. It's listed right here, radio frequencies. Radio freak. Beautiful. So we do radio freak, and then we check if it matches the old, or I guess the knob rotation indices. If it is, then this room is the one we're supposed to be targeting. Okay, so let's do var targeted room. Let's do null. And then here, targeted room becomes whatever entry we're looping through, and then we break. Okay, now when we calculate destination, we actually need to clear the targeted room. And then we go through all the frequencies, check does any one of these destinations have the correct frequency, and if it does, we set it here. Okay, so print. Let's give that a test. Not changed. Okay. So it's not reacting to anything, but that's because we're not really pointing it to a particular frequency that works. So let's do what? 660. Okay, so 6 I think would be 7. 6 0 1 2 3 4 5 6. And then 0. Knob's changed. It might be the wrong order. Okay. Actually, no. Hold on a second. Wasn't there something that we have to add +1 to? Everything we have to add +1 to. Just print the current indices as well. That will be the next logical step if I don't figure this out. Okay, 0, 1, 2, 3, 4, 5, oh yeah, 6, 7. What the heck? Okay, yeah. You know what? Hold on a sec. We're here. Let's give it a quick test. I'm gonna go to comms room large. Okay, the machine should still be here. Maybe realigning that light might be a good idea. This looks like ass. Also, baking those lights might be a good idea too. Let's see. So 3350. Might have to increase that text as well. Alright, so. Oh yeah. Viewport rendering is also not working here. So 3, 3, 5, 0. Plus would be a good test to see if something crashes. There we go. Alright. One. 2. 3. Yeah, nice. Okay. So 1 and then 420. 1 and 420. So 1, 420. Nope. Okay, that looks cool. Yeah, I am a huge fan of like old technology, especially when it's like involves interacting with it. So, yeah, you're right. We definitely need some sort of a lights on those knobs. So, okay, it didn't actually match it. You know, it would be helpful if I ran the function that actually matched it. Whoops. Okay. Um, I guess that's fine. Will light maps work with randomly placed buildings? That's my actually concern. That's my concern. It might not. I'm wondering if it's possible to bake the lighting for each individual room, and is that lighting going to be functional within the level? I'm hoping it is. I'm sincerely hoping that it is. Because if it's not, we're going to have to figure something out with, like, calling for all these lights. Okay, we don't need to do this again. I could just drop a radio detector here. Bake every scene individually. That's my hope. If that's the case, then damn, dude, no problem. Hell yeah. Okay, so, whoa. What do we got here? 171. So, 1, 7, and then target room null. Okay, and then 1. Target room. Yeah, you know what? Let's print. Did we? Yeah, we used to print. I'm not printing it anymore. Knob's changed. Let's do knob. Indices. And then we're going to do this. Let's give that a go. The code should work fine. It didn't work before. This is a new piece of code. It's just matching two arrays, but we'll see if they're actually being matched. Let's see. We don't actually need to go anywhere. All right, radio frequency 561. Okay. Oh, the knob is the last number. Okay, so 0, 1, 2, 3, 4, 5, 6, 1. That's 541. Huh? What? Excuse me? Where do we get a 6 from? What? Hold on a sec. 561. I think my indices might be in the wrong order. You can use a baked light map or GI probe. The baked light maps is less resource intensive than GI probe. GI probe is real time, right? Because baked light maps, I think, would be perfectly fine for something like this. Okay, so hold on a second. This goes up to 7. This goes up to 4. This goes up to 7. Okay, yeah, so we screwed up on the index somewhere. So large frequency, small frequency, channel. I think if we just rearranged it a little bit, that might be okay. Channel, major frequency, minor frequency. Right. So maybe we can do the opposite. So channel, so it's major frequency, minor frequency, channel. Channel is out of 8. Minor frequency is out of 5. Okay, so it's just a matter of having the wrong order. GI probes are dynamic, unlike baked light maps. Can we bake in individual light maps in each scene? Like, I have a separate scene for this room, right? So it's a separate scene. Can I go to this scene, bake the light maps, and then drag and drop this scene into the main level? Good. Okay, cool. So, got me worried there for a second. All right. That is perfect. I don't need the propane canister. What the heck? I don't need the pry tool either. What the... There we go. Well. Sort of a panel on the backside might be nice also. Where did the batteries go? Alright. So let's double check this. 652-334-734-133. Everything seems to be 0, 1, 2, 3, 4. And this gave us 5. Because, well, hold on a sec. This is not randomness. This is a for loop. For loop will loop as many times as we tell it. So hold on a sec. 1, 2, 3, 4, 5, 6, 7, 8. So channels are 8. And then 1, 2, 3, 4, 5 gives us 5. But it should have been 0 to 4. So how the shit did this end up with a 5 in it? What? Hold on. 4 min f in 5. This will result 0, 1, 2, 3, 4. Right? Where the shit is it getting a 5 from? Oh, I messed it up. Oh, well, hold on. God damn it. It doesn't matter if I replace these. I need to change this order. Oh, God. Okay. I think channel has to be the last one. Major frequency, minor frequency channel. Didn't even need to redo this whole thing. 8 channels, 8 major frequencies, 5 minor frequencies. Cool. I went on a very long drive today to pick up some stuff for our home daycare. Some very, very well priced kid chairs. And on my way back, I couldn't resist. I went to Cosmo Music, the music store, and I kind of stood around. Just looked around, picked up a book on slide steel, lap steel guitar, because I'm gonna definitely need to write some like country lap steel music for the Atomicon radio. That was an interesting thing. Kind of look at all the synthesizers on the walls, and I'm like, I don't need one, but I kind of want one. And this despite the fact that I already have just synths up the wazoo. I didn't pull a trigger. Don't worry. Watching you work just makes me want to jump up and do shit. You know what? That's how I feel anytime I get to work. 707. Also, the prospect of not living homeless in Canada is another reason why, I can get on and get my ass to work. 707. What do we got? 7. So that's... It's not supposed to be using the last channel. So, 7. No, actually. Yeah. 70. Wait, 707? I'm losing my damn mind here. How did it get the channel of... Oh. Channel is the last one. Being homeless in Hungary is probably not... Yeah, I know, you go hungry. Oh, I'm so sorry. We got channel. The Easter egg frequency, yeah. Well, it's kind of there. But this is... I keep goofing up the order. Channel is 7. Yeah, so it gave it, like, the last channel. It's not supposed to give it the last channel. The last channel is meant for something else. Okay, so what we need to do is it shuffles the list of frequencies. You know what? I know what we need to do. We need to make sure that it never assigns a frequency that has a channel of 7 to any of these rooms. Those are left for the Easter eggs and all their other stuff. Okay. So match, no match found. Check if this value is already present. Isn't this redundant? Because we use pop front, which removes the value. Oh, hold on a sec. This is for what? Check if this value is already found. It's a 4-digit number. Generates the number. Checks if the number is not found. This is a... Ah, right. Okay, this is a separate process. And it's a while loop too. So we break here. Ah. Okay. Interesting. Okay. I need to make sure that I don't forget what this does. The comment only helped marginally. Right, we pop front the frequency, so we need to make sure that it only pops front the one that doesn't have channel set to 7. So what, do we just like continue shuffling them until we get the one that is in front? Let's try this. Shuffle frequencies until one is found that isn't channel 7. Number 8 on dial. Okay. Cool. So here we shuffle it. I guess we don't need to shuffle it there then. So we'll do... we'll shuffle it once. And then here, while, get the frequency map, access the last value, 0, 1, 2. If it's 7, shuffle it again. Cool. So this should avoid having any room actually use that last frequency. Oh, interesting. 2 equal signs? Yes. While radio locator. Oh, wait, hold on a second. We need to access the first set of frequencies because we're going to be popping fronts. We're going to be using the front one. Cool. It is a loop within a loop, yes. But it's only a one-time thing that happens at the very beginning of the game, so that's fine. It's when all of the random generation has to take place anyways. That's where the loading screen's gonna be visible. Yes, we are loading stuff. Don't you worry your little head. 411, 611, 705, 314. Nice. Alright, so let's try, I guess, 411. Can I get rid of these mouse-entered, mouse-exited prints? Get this out. Get this away. Okay. Loading bad code or something. The funny thing is it's quite literally just an homage. All you're doing is you have some sort of a loop that is preloading like materials and stuff. You know, if you ever like run your game for the first time and it stutters for the first 10 seconds, that's basically what the loading screen is there to obscure. And then you do some clever stuff like Bethesda with their like asset preview with something rotates and you put it on a separate thread and the loading doesn't cause that to stutter. Okay, so what are we searching for? Searching for 544. So, what's first? And I forget. Where is it? Master node. Major frequency, minor frequency channel. Okay, so 0, 1, 2, 3, 4, 5. 5. 4. And then 4. Commissary. Look at that. Okay, so hold on a sec. Let's try a different one. 715. So 7 1 5. Comms room. Yeah. It's actually working. Loading screen under the curtains in the theater. That's right. All the viewers see is just the pretty curtains. They don't see the commotion, the panic, the anxiety, people questioning their life's choices in the background. Doing lines of coke. Try to calm their nerves. Cool. Okay. Now, if I teleport my butt over to the... here... this layout is starting to warm up to me. Maybe I just needed to sleep on it a little bit. Okay. I think we need to lower this down a bit, though. Let's try... security checkpoint A, 2969. I really like this mechanic. Yeah, it's honestly turning out to be one of the most kind of engaging mechanics I've put together. 2969 was it, right? Okay. 0, 1, 2, 2, 9, 6, 9. Okay. Hey. Okay. I think I may have disconnected the randomness. I think it's just always stuck on the first one. Pull. Oh. Pull. I can also imagine that we can make random horrors take place when the players are engaged with this. Like they look down and look back up and there's a thing standing in front of you. Alright, there we go. So, channel 3, 325. Channel 3. And then 325. Now, it doesn't remember the previously entered elements. And also right now it doesn't show me... Channel 3, 325. I think the indices have changed. Okay. So the indices have changed here. We're doing major frequency, minor frequency channel. Let's take a look at the decoder output. Okay. Channel is 2 now, which is this one. And then... so, 2... and then 2, yeah, so this is 2, and then this is 0, and this is 1. Okay, let's give that a test. Hello, how's the game dev going? Going pretty good. I think we might be able to wrap up finally the radio detector, because I do have sounds Sounds have been delivered by the almighty sound wizard by name Cole Harmon. We are going to place those in. I just need to make sure this is working. Okay. Let's go 3, 9, 2, 1. Zero, 1, 2, 3, 9. Whoop, 9. That's right. 2, 1. All right, it's gonna be this one again, eh? Yup. Okay. Well, it is the fastest one. Says I as I completely fail it. There we go. Okay. Nice. Okay, 4, 225. So channel 4. Yeah, definitely need those light ups. 2. Oh. Hey, Jezebel dorm room. It works. It works. Let's try another one. Whoop. Get back here. Okay. 7670. Seven, 6, 7, 0. Pull. Oh, this thing is still running. Huh? Did I screw that up? Oh, I didn't pull it. There we go. That's 1. Oh. 2. Oh, come on. 3. This thing should turn itself off afterwards. Get 4255. Channel 4. 255. Security off is 1. Yes, it works. Okay, so now all we need to do is make the radio actually make sounds. Audio, stream player. We're gonna see if we can work with audio stream player 3D. It might not be necessary, although technically I think it should. Okay, so what's next? Technically, before we can even do the audio stuff, we need to do the whole angle interpolation stuff. So targeted room is here. Targeted beacon. Set it to null. Now comes the game changer part. Let's see. So targeted room equals entry. We break. Okay, and then locate the beacon according to this destination key. Okay, now in one of the previous streams, we had made a beacon object. And it is something that we place. Where do we place it? We placed it into this security checkpoint area. Where is it? Comms room, auditorium, dorm chunk. Well, bunker security office. Even though it's not really all that security or officey, it is very officey, not very security-y. Okay, disable lighting and stuff. Here it is. Okay, so this is what's gonna act as our beacon. Look how fast this scene is. Okay, I'm gonna do this. I'm gonna place this into a group. So destination beacon group. Whoop. Don't know what that was. Dang it. I placed the audio player into it rather than the top node. Let's give it a script. Destination beacon. And this script is not really going to run any logic except for just sit there and give us an export variable. So, what do we got? Props. It's technically a prop. Sure. Okay. Bacon key. There we go. Beautiful. By the way, if anybody's in the chat, and if you haven't already, toss a sub to the Retroactive Gamers channel. We are hurting and struggling for every single sub. We're downright sucking dicks out there. Link in the description. Let's give it the... Okay, we don't need to give it the key here. We're going to give it one here. What rooms do we have available? Commissary? Communications office, Dr. Whitmore office, security office 1. So I'm going to copy this, place it here. And now, that's it. That's literally the entire job of this object. It just needs to exist in the group and have a key in there. What we're going to do is go to the radio decoder detector. And then here, we're going to loop through these nodes in the group. For each node in, get tree, get nodes in the group called security. What? The group is called destination bacon group. There we go. And then if each node dot bacon key is the same as the target room that we're currently looking at, then that's the targeted beacon. Bacon. Scientist from Half-Life 1 or Dr. Kleiner from Half-Life 2? Why not Dr. Kleiner from Half-Life 1? I know people find that shine very menacing, but damn. Stop! Okay. With my brain and your brawn, we'll make an excellent team. Target beacon. So that's technically it. We need to clear this as well in the beginning when we do this. Okay, now. Greetings. So we're gonna do this. If the... Oh, really? Come on. If the targeted beacon is not null, then there's got to be something to follow. What are we doing here? Should we hear static all the time? They're waiting for you, Gordon. In the test chamber. Nice. Love it, man. Such a classic. Oh yeah. We did a Let's Play session of Half-Life 1 where Tim was playing the keyboard and I was playing the mouse. Jesus Christ. It was not coordinated, to tell you the least. And then we switched, and it was even worse. The amount of blaming for incorrect, movement or bad aiming, oof, that's a lot. Target beacon, not equals null. So then, I guess we could just start playing the sound first. Let's do static SFX. So we have the radio sounds, we have the beep, we have the loop, we have the static. The beep, the boop, the hoopity hoop. Okay. Targeted, beacon not null. I guess the first thing we need to do actually is calculate the angle. So var angle diff. This is a mechanic I have already programmed in the past. In the Angler prototype, there was a special device which you used to find crystals, which are like little energy sources. You can point them, point the whole thing left and right and up and down and find where it is. That was a really cool cool mechanic. So we already know what needs to be done here. We need to calculate the actual angle between the player and the object. So I guess we can do between the beacon. So global transform origin direction 2 targeted beacon global transform the origin. This gives us a vector. Now, can we do a dot product on the three-dimensional vector? Yes, we can. Beautiful. Now, how does it work? Vector 3, dot product will be 0, straight, 90 degrees, negative 90. When using unit, normalized vectors, result will always be between negative 1 and positive 1. Got it. Okay. So, we need to get the direction of where our camera is looking at. So, I think we can do var dot. We're going to do the dot product from this angle to what? I think we need to get the player's camera. That might be wise. Now this does have a generic item script that I have to click a million times in order for it to be opened. There we go. Generic item. And it has a player reference. And if we're lucky, maybe even a camera? Nope. Okay, that's fine. If we have the player, we have the camera. So we do... Maybe, actually, hold on. Maybe we should give it a place to store the player camera. If it's needed, then we'll have it. Let's say players populated here. Player cam is going to be player.getNode. What node are we getting? Player. Cool. Copy path. Get it here. Rotation helper, camera buff, camera wiggle, camera. Cool. So now we have, it's a one-time thing, so we're not constantly getting the nodes over and over again. Let's get back to the radio detector. Player cam, global transform dot basis dot z. So that's the forward-facing direction of the camera. Now, print dot dot. The dot product. Okay. So this is the comparison between the two angles. Re-importing my soundtracks to Godot for looping breaks them. Breaks them? In what way? Alright, let's see. 726. Okay, now which one was it? 7. 2. Commissary. Okay. Now at this point, it should be printing the dot product. Oh, wait. Commissary. Right. There's only one location in the game that has a beacon, and that would be the science thing. They aren't playing anymore in the editor or the game itself. Double check that your loop isn't set to, like... I guess that wouldn't really make sense. Are you in Godot 4? Okay, let's do that one more time. Security checkpoint. So 520. Okay, so it's 2, 3, 4, 5, 2. Oh, we crashed. It failed to get the player cam. No, evaluate index player cam on base vector 3. Am I stupid? This is what I'm supposed to do. Calculate the dot product. With a long strike. Does it stop working after attempts to loop or before? Okay, one more time. Secure checkpoint 330. Okay. So 0, 1, 2, 3, 0. Oh, hey. There we go. Well, I mean, there it is. And when we look away, it seems like it is positive value. So 1. Yeah. And then when we look this way, well, that's actually kind of curious. I think it's just backwards. I think if we could keep going this way, we will reach it. It's just a matter of calculating the... Oh. Yes, calculating it from and to the opposite direction. Nope, we reached the end of the world. Okay. Alright, so what gives? Supposed to go negative? Oh, we're hopping trees now. Oh. Hey. There we go. Okay, yeah, cool. So it's just negative value. We just need to calculate the angle not from the object to the player, but from the player's camera to the angle to object. Have to re-import the loop. If it's a WAV file, WAV files can store loop points inside of their file data. You can go to the import and then double check if it's taking the loop point from file or if it's taking it from like your custom set in the editor. Okay, one more time. I mean, I'm pretty sure it works. Let's go 441. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 1. There we go. Okay, so when it's closest to 0 now, I believe that's when the angles are correct. So, boop, boop. Interesting. Well, this is weird. It's taking me in circles. Yeah, we're in the marshes now. That doesn't make sense. Player cam global transform dot basis.z dot angle difference. Angle difference is not between the player cam. I think that's why. So we do player cam dot global transform dot origin to the targeted beacon global transform dot origin. Let's give that a go. Godot is good for beginner. Unity is better. I don't know about Unity, never used it, but I know that Godot is better than GameMaker, AppGameKit, or LeadWorks because of how many nodes it gives you that just do all the basic stuff for you, and you don't have to do it yourself. I appreciate when an engine saves me time. Especially when I'm a solo developer. 410. So 410. There we go. Okay. Hold on. Aren't we supposed to be going to 1? Yeah. That's why it was like this. So it's going to 0, which is the 90-degree angle away from the camera. We're supposed to be going to 0.1. Or 1.0, I should say, which technically we can never reach 1.0. And we're... Oh, God. Okay, so that's a nada. So what, negative? Oh, we reached this location. I'm pretty sure that... Yeah, there it is. And then when we go past it... Okay, so we still need to go to the negative value. Okay, now it's positive because it's directly behind us. It's new or less learning material. Man, I gotta tell you, the documentation for Godot is pretty damn well written. It helps if you kind of dabbled with programming in the past. Okay, so the dot product is negative. This is weird. What should happen? We should find this location. Oh, jeez. That terminal's loud as shit. So, yeah, so it looks like the dot product is negative. Maybe it's because I just need to, like, take... What? Oh, you know what? Hold on a second. Z is negative. That's positive Z. So and the camera's pointing that way, which is negative Z, which is once again the whole Godot being a right-handed blah 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 system. Okay, hold on. Let's just do this. So take Z. I think I can do like this. Negative Z. And then make the dot product, which to be honest, I mean, we could just invert the dot product and still get the right value. But let's double check this. So backward, negative Z is forward. That's why we were getting the opposite direction, even though we flipped the calculations. All right. Fair enough. Cool. What are we looking for? 433. Nice. Okay. So now we're looking at that. That's +1. That doesn't look right. Pretty sure it's... maybe it's not. Hold on. I am fairly certain this is not... Oh, it is. I was going to say, I'm fairly certain this is not going to take us, because I'm pretty sure it was to the left. There we go. Okay. So now... now it looks like we have a way of seeing where the beacon is. So all we got to do... Like, we can discard anything below 0. Because that's just incorrect direction. We can say, as long as it's above 0, we can take the number. Okay. Take the number and translate it, first of all, to the needle position. Where's the needle position? Needle. Okay, what are the angles we're working with? Okay, that doesn't help, because the needle is in global space. What we can do, however, is this. I was experimenting with a possible layout for the comms room. Don't forget that. Forget about that garbage. Let's get to assets, models. Where's the radio detector? It's like items. Radio detector. Doesn't it have built-in basis t.z function? It might. We're going to see in a moment. All right, so here's what we can do. I'm going to take this empty. Okay. I'm going to... This empty is for... All these empties were set up for texturing as locations where I can place these knobs, but we've since then discovered that we can just tell Substance Painter to not do casting of ambient occlusion baking unless we specifically tell it to use other objects. It could just be baking only stuff with the same name. So we're gonna move this stuff to empties. Disable, because all these empties are actually exported as these empty spatial nodes in the scene. But I'm going to take this one. I'm going to parent it. But I'm going to parent it in a way that takes over the inverse. Then I'm going to unparent it, so Alt-P, with keep transform. And now I'm going to take this one and then parent it without an inverse? No. Hold on. Keep transform. All right, what is the rotation of this now? It's something. Oh yeah, that rotation is kind of messed up. Okay, logic would dictate that this object is perfectly within this object, which means it should have cleared. Maybe I can apply rotation. Yeah, okay, we can work with that. And I think, can we, I think this should work. Let's export this. If I apply rotation, it did go to 0, 0, 0. As long as it's a child of that empty, it should technically maintain its relative parenting. So let's go to Dreadtail, Engine, Models, Props, no, Items, Radio Detector, Godot, Export, dear God help us. Okay, open it up. Cool. Now, the needle is all sorts of messed up. Okay, so that didn't work because the axes are all reset. This one, however, technically could be used, but that was exactly the opposite effect I tried to impose on it. Making a child of the empty means that I can have the empty be rotated this way, and then the needle could just be rotated along a single axis, like y-axis, right? Which, as you can see right now, that's 0, 90. Oh, shit. Hold on a second. 180. Negative 90. Yeah, so you see, I could just rotate on this one axis, but what is this? Why is this here? That doesn't make sense. Transform. Is this global transform? I mean, here, the needle is 0, 0, 0. Delta transforms. Yeah, what the heck? Transform in the inspector is always global. Okay, so we don't apply it then. That is a no-no. Okay. There we go. I'm going to export it again. Reload. Open. Go back. Don't need this. Needle. Yeah, okay. It's still messed up. Although that transform is in local space. Yeah, you know, this is another thing. Why can't we have a local rotation in the inspector? That would be so useful. The Godot inspector, yeah. Well, I think it might be the case in both. But anyways, technically, if I look at it this way, 0. Yeah, that's terrible. Okay. Here's what I propose. I propose. This is already a child of this object, but this object has some really messed up angle rotation. So I'm just gonna reset it like this. That's looking good. This is pretty much straight on. I'm going to reset the rotation of the needle. I'm going to take the empty now. It would be nice if there was a way to just do this with parenting and inversing, but I guess that's fine. As long as it's relatively straight. There we go. And then we export. The needle is relative 0, 0, 0. Reload. Open anyway. And okay. So now, if we rotate, no. See, that's not what I want. Its global axis matches the local axis. Oh, wow. That is all sorts of messed up. Hmm. Then it was not tilted. Okay, that is kind of confusing. The needle is inside of the empty. The empty is the one that's rotated. The needle is not. So, oh, well, that actually kind of tells us everything we need to know. So RZ. Let's do local axis. RZ. Yeah, okay, so the local axis is all sorts of messed up. Hmm. How do we screw it up that bad? Dang. Twisted system. Hello. Good day. Orienting the whole object so the needle is at 0, 0. Apply rotation, then orient back. That's the next logical step. But the needle is... Oh. Well, that flippin' explains it. Hold on a second. That. The needle is... that looks like Euler angles, rotation, and Euler's... Hmm. Okay, hold on. I'll just do it like this. See, if we have to do this, there's no point to the empty. I figured I could just resolve it with empties and just having it inherit the transforms and all that jazz. But nope, it wants to be a bitch. And not just a half bitch, the whole bitch. All right. So local axis. Son of a gun. It's even the most screwed up in here. What the hell? I can't reparent it in Godot. Because as soon as I reparent it, it's gonna notice that the node is missing and recreate it. Hold on. Okay, I'm gonna try something. I'm gonna unparent it. Clear parent, keep transforms. Actually, might be a good idea to do this when everything is nice and straight. Okay. Alt P. Keep transforms. Apply rotation. Yes. And then parent. Cool. It's almost like it's in reverse. Where's the damn needle? It's what? How are you? Oh, wait, hold on. We're gonna lose materials if we do this, but I think I have to. What the heck? We clearly reloaded the scene. Can't save this. But the inherited scene doesn't update. I swear, we're this short to losing scene inheritance. You see this? What? Hello? Same. Yeah, this is reload. Okay, hold on. Let's follow the wisdom. It's a ghost scene. Now watch the inheritance be broken when we get back. Okay. Okay. Let's open up. Radio detector. Yeah, if you mess around with the scene too much. Oh, wow. Okay. Cool. Let's hide this. Let's take radio detector, GLB. Place a new one in. See, this one's fine. Editable children. And then, hey, and the needle is fine. Hold on. Yep, the needle's fixed. And this one's fixed, so I guess it's a bum reference. Man. I don't know. Maybe Juan should fix this before, putting more stuff. Or get somebody on this. God damn. This is just embarrassing. Alright. I don't like using inheritance scenes because it's too buggy. Yeah, this happens once in a while. Not too often, but when it does, it's kind of annoying. And I like using the inheritance, not because of the bugs, of course, but because it really helps with updating files, except there's so many these little bugs that I have to work with. Like, you have to reopen the GLB file in order for it to update in the GLTF. They fixed it in Godot 4. Why can't they just backport it back to Godot 3? Radio detector. Where the hell is this thing? There we go. Okay, at least applying the materials isn't too difficult. Okay. I just goofed up. Hold on a sec. I just goofed up. Because this radio detector has the area nodes. I should probably take those out before I go off destroying stuff. There we go. There we go. Okay. Let's pray that everything still works. Can't loop begin or end. Finally, just loop the whole track. Place 2 seconds of the 36 seconds. What operating system are you on? Please don't tell Mac. Please don't say Mac. And also, please don't say Linux. Just don't say anything. Never mind, I asked. Okay. Windows. Okay, well. At least the control group is the same. Okay. So, this should work now. Right? We got the needle. We can rotate the needle. Yeah, look at that. Oh, yeah, and look at that. This is in the local axis by the looks of it. So, 0, -80. Okay, so -80 goes to the right, and a +80 goes to the left. Okay. Cool. So what we're going to do is we're going to borrow that little script, the map values. Little function. I don't think it's here. And also, I think it would be great if we could exclude. Oh yeah, we can exclude. Hold on a second. Find in files. Only search the scripts folder. And then map. Remap range. Hey, nice. Remap range. So we need this function here. I'm going to borrow it. It is a very handy function. Radio detector. Pop it down here. And then we're going to make use of this function, I suppose, over here in the process. So, first of all, we are only interested in the dot product being over 0. So let's do this. We might want to rotate the needle despite if there's a target or not. We're going to say, let's make a variable. This is going to be signal strength 0.0. We're going to use signal strength here, signal strength, and at the most minimum, which is 0.0, and maximum is 1.0, it's going to remap to -80, which is, I believe the needle is to the, where? 80. +80 is the minimum, -80 is the maximum. Okay, now this is going to be reset right here. If there's a beacon that we can follow, we're going to say if the dot product is above 0.0, then signal strength is going to be the dot product. And then this remapped range is going to be fed into the rotation of the needle. Dot Y. Okay. Might need to clamp it. This should act as a clamp, then so it never goes into the negative values. Okay. Let's give it a base test. Why are we loading so long? What happened? Null instance. Each knob. Oh, right. Each knob. This is where we have the knobs. Right. Radio detector has to make sure that the name is the old name. Make the dot in APS. So even if they're facing backwards, it still reports as they're facing the right way. What the shit? Oh, jeez. Null instance. Rotation degrees. There we go. Dot is always -1, +1. Yeah, that's very useful. Okay. You know, Godot editor should have a stutter detector and then tell you which material was being compiled as a result of it, so that we can preload it, or like which resource at all, not just materials. It does have a profiler, yes, but the profiler just says draw calls or rendering stage or physics function, right? And which physics function? Like half of the shit here is physics. Which exact component has caused it to go over the edge? Or like tell me what has been, colliding at the point, running its active collision calculations that has caused it to go over the edge, right? I mean, I would imagine it's fairly simple to detect when literally the frame goes, "Hey, everybody, okay, we got the game running." Right? Channel 3.5. Something that logs which material is being compiled. Yeah, that would be super useful, because I think that's one of the biggest issues with stutters. What are we doing here? Checkpoint 523. Alright, what the shit is this? Huh? What happened here? What are we scanning in between the... Hold on. I literally just re-imported the mesh. Why is this different now? Okay. I have no freaking idea. Okay. What is it? 523, was it? Okay. Five, 2. All right, there we go. Okay, so that works pretty well. It's too hard set, and it's too wide. But we can work with that. Okay. I don't think I accidentally applied rotation on the dial. Maybe I did. Oh god, no. No, 90 degrees. 0, 0. It's kind of annoying. Do we need to... I think it's an even number, so 360 divided by 4 divided by 2, 22.5. I think if we shift it by 22 degrees, it'll just work. 22.5, but it's also spinning in the wrong direction. So, All right. One step at a time. Why don't we just do the needle thing first? So first things first, I want to make it a much narrower window. And to do that, we can technically do it mathematically. I could say, where is it? There it is. I could say that it needs to be above 0.7. You can raise the dot to the power of 2. Well, okay. Raise the dot to the power of 2. Isn't that going to make it dot times dot? Is that going to be twice? Exponential easing to 1. So, on that regard, the approach that I was doing before, which we could technically still do here, is to give it a curve, and then use the dot product on the curve, and then we have like a physically fidgety thing that we can mess around with in order to dial in how sensitive we want it to be without having to do some math. So I would do like resource, curve. I think we just do this curve and then give it a name. So this is radio detector curve. Okay, radio detector curve. And then we can give it a point like this. And then we can basically just propagate that point. Can we, I guess we just have to add another one. This isn't Godot 4 with the fancy curves. We just do this. And then we can make it kind of propagate like this. So you gotta be looking at it relatively straight. So it's only gonna start reacting when you reach around like this point. Right? Cool. Cool. So we're gonna do sensitivity curve. And then we're gonna preload this resource. Curfew. Sensitivity curve. Preload this. And now when we go down here, we already know that this is a value between 0 and 1. So we can propagate it from 0 to 1 and get the y-axis, which is also 0 to 1. So here, we don't remap the signal strength. We're going to talk to the curve. And then there's a property that we can use on this curve. Not online. Called get point position. No, get interpolate. It takes an offset. Maybe even interpolate baked. I think interpolate should work okay. It takes an X offset and then gives us the Y position along that X offset. So we give him one of these values, he gives us one of these values, where across the curve we are. Signal strength is going to be fed in here. And that's it. So 0 to 1, 80 to negative 80. And this is still going to make the needle jump straight to it. Can implement decrementing with a signed value as well to add some wobble. Yeah, that's absolutely a no-brainer. Okay. So 216. Okay. 216. Commissary. All right. Except... No? Was it not 216? Oh, there's no commissary in the level right now. So 622. There we go. And then you can see that it's much, much more sensitive. So it's a much smaller window. Cool. And then right now it's instantly reactive. We're gonna instead lerp angle. I think, I'm pretty sure, because it's a negative 80, positive 80, it doesn't go cross over the 360-degree range. So I think we should be able to just smoothly transition this way. I don't think we need to do lerp angle for this. Divided by 10. Divided by 40, actually. We need to make it a little bit more delayed. Okay, God help us. Let's hope this thing doesn't helicopter away. What's the difference? Does interpolate constantly check if the curve changed? I think the baking allows it to like pre-calculate all the values. Actually, instead of talking shit, why don't we just learn? Let's go here. Curve, interpolate baked. There's a bake function too. Recomputes the baked cache of points for the curve. Yeah, I think that's exactly what it is. Like, instead of doing a bunch of vector math and calculating if the curve is here, then what is the value going to be here? It just creates like a value table or lookup table, and it says according to this discrete value on the x-axis, the y-axis is going to be this, and it just uses a lookup table for this. Interesting. All right, I don't think that really matters for us. Cool. Cool stuff. Learning something new every day. All right. What are we looking for? 406. 0, 1, 2, 3, 4, 0, 6. What? 406, right? Hey, there we go. Nice. Okay. The game jam, the jam game has soundtracks now. Never again. Is it really that bad? Okay. So this looks pretty good. I'm hoping there's a way we can maybe smooth out the camera jitter. Or the mouse movement jitter. Okay. Sure. I think that works. Maybe we can narrow it a little bit more. Oh, easy now. Beautiful. Ah, there's the bake resolution. That's cool. And then let's slow it down even more. Let's go like 80. Do. Don't need to go there. 513. Dang it. Nice. Mm-hmm. No, the standard yellow is not the target. It's when you're looking at the target, it goes into red. So, and then as you start looking away, it loses the signal and it goes down. Okay. Now, sounds. Let's see. So we have the static. We can make it autoplay. And it is looping. So that's good. Although it's going to play as soon as we enter the level. Maybe it should play. It will attract the attention of the players. Okay, it's biased to the right. Okay, we don't have the clicky sounds yet, but we do have the beacon. Okay, so let's get another sound. Beacon. We have beacon close. We're gonna give it a timer. Beacon timer. I think it's every 3 seconds. Get the timeout. Okay. We need to preload the sound of the beacon. Okay, it's actually just going to be an array. Preload it here. Nice. Bacon. Let's get beacon close. We're going to set stream to a random sound based on the size of this array. And then tell it to play. Now, the volume, we got beacon close. The volume is going to be controlled by how closely we're looking at the value, at the target. So I guess this can just auto start, that's fine. And then right here, when we calculate this, signal strength is 0.0. It's always going to be positive. So we're going to say, Dan, come on. Beacon close. What is it going to be? What's the property? Unit dB. Unit dB is going to be equals to what? It's at 0 if it's full normal standard volume. So it's going to be, let's do -40, which is like -50 is basically pretty much silence. I was considering making the timer, the frequency of the beacon based on how close you get, but it didn't really make sense. And I know that I'm not really first to argue that a mechanic has to make perfect physical sense. Sometimes experience is better than realism. But it doesn't seem like the beacon that, the beacon is this object in this another room, right? It's the one that's actually producing the radio. It's basically like a sonar beep. Right? So the solution to that, by the way, that we decided is there's actually a washed out beep, the one that you listen when it's far away. Like this. And this is what you're going to hear when you're far away, but it still allows you to home in on it. So we're going to basically make this distant one be quiet as we start approaching. And as we get closer, we'll just switch to this beacon. They'll just have to play both at the same time. But for now, I just need to make this beacon become audible when we're facing the right direction for the time being. So the default volume is -50. And then from it, we're going to subtract +50 times signal strength. Signal strength is usually 0 until we look away or look towards the object. So if this is 0, this is 0, so the volume of the beacon is -50. And by the way, signal strength, yeah, I think that's fine. We don't need to remap it. All right, let's take a listen. You can use unit size too, yes. That could act as a secondary option. Okay. 624. 6. Come on. Oh, you can kind of hear it. Nice. That's really haunting. I think we do need to work on pushing it through that that remap value. With the static, yeah, it's really creepy. What do we have here? Interpolate. We might have to make another curve. Remap range. We don't need to remap the range. We just need to parse it through the sensitivity curve. Okay. Technically, I wanted to make the beacon punch through the static, so we're going to make the static also duck down a little bit. So we're going to do static sound of sfx dot unit dB. So we're going to make it negative. Let's do -15 times this. So it's going to duck down and give room to the beacon. Because that's kind of how radio works. You can have a signal that just takes over. So 4. Two, 1. Is it 4 to 1? 4, 0, 1. Minus 15 might be a bit much. I'm gonna make the needle nudge a little bit every time a ping takes place. Needle, ping, nudge, 0.0. And then every time the ping is played, it's gonna be, let's do like an extra 8. I think it's negative is all the way on the right, so we're gonna do negative. Oh, I guess that's fine. And then when we go here, the needle rotation, it's gonna go remap range, which ends right here. We're gonna add to it this little nudge, and then the nudge is going to 0.98. It's gonna dissipate over time. Okay. As a matter of fact, maybe if we don't want to deal with values like degrees, I'm just gonna do 0.1, and then we're gonna feed it into. Oh, we can't feed it into remap range, although I think we can. I think this might work. Also, I gotta reduce the decibels, so instead of negative 15, let's do negative 8. Mm-hmm. Six, 1, 1. Yes. Maybe it can reduce a little bit faster. I like it. Tiny little detail. Let's do 0.95. Mm, 344. Oh, the beacon is still active even though we haven't homed in on anything. Okay. Let's make it a bit more prominent. We also have double interpolation happening, smoothly transitioning the needle and smoothly transitioning the whatchamacallit, the object, the value. Oops, come on. Overshoot and bounce back. Yeah, maybe. 413. Hmm. All we have to do is make the radio decoder not slam in our face when we're running forward. Nice. Okay, so all we have to do now is figure out distances. The sound should be in Subnolaris too. I'm sure we'll come up with some other stuff to put there as well. I'll be talking to some sound engineers to see whom I can get for Sublunaris project. I'm sure everybody is just kind of looking for a project to work on, so, you know, works for me, because I need sounds, and I don't want to do them myself. And people are looking for projects to take part in, and there you go. All I need to do is have the discipline to finish them. Which I'm pretty sure with really good quality sound, I think that's going to be a pretty motivating thing to do. Hearing it to, listening it to what the game sounds like. So we have static beacon close. And can I please just duplicate this? This is beacon far. We might have to redo the far sound though. I feel like something more deteriorated, like the same beat but deteriorated, might be a little bit better. Like we could pass it through a bit crusher. Only polygon 2D notes for sprites. Nice. That's an interesting limitation. Static loop, ghost loop. Okay, so this is beacon far. That's right. So what do we need to do? We need to calculate what kind of distances we are going to be working with. So if target beacon not null, let's calculate the distances. So print dist to beacon, target beacon, global transform dot origin distance to global transform dot origin of the radio locator. All right. Let's take a look at what kind of distances we're going to work with on average. Okay. Right now it's just playing non-stop. We'll fix that after. 2, 4, 3. Okay, distance to beacon, 192 meters. Hmm. Kind of like the way that layers. So 200 meters on average is what we're looking for. I think maybe we can double that. So let's say the maximum distance would be 400 meters. That's the furthest distance we can have. Okay. So let's do var dist to target. Starts with 400. Then we're gonna, if the targeted beacon is not null, we will calculate the actual distance. And we need to clamp it, I believe. Clamp it between 0 and 400. Okay, so 0 and 400. Cool. Now, at 200, we're going to start hearing the other beacon coming in. So from 200 up to 0, that's when the other beacon needs to start coming in. So I think, once again, we're going to rely on a curve to help us dial it in perfectly. I think that's the easiest way to go. So duplicate radio detector distance curve. Okay, so we're going to say that everything from 400 up to 200 is going to be the far beacon. Then once they start crossing the 200 mark, we're going to start getting into the clearer beacon. It's going to start transitioning, and then closer to the final distance, we're going to hear the proper beacon like this. Okay. Which kind of makes me wonder, why can't we just go from 200 to 0? So say 200, clamp it, and then when we go from here, maybe it's got to be 300 actually. Go from here up to the final point. Cool. Okay. Let's make a variable called crossfade, beacon crossfade. We are going to distance fade curve. We're going to preload it. And cool. Let's go over here. Beacon crossfade. So we're going to talk to the curve. Interpolate. Interpolate what? So we know that the distance is going to be between 0 and 300. So we can take the distance divided by 300.0, so it's a float. And now, if it's 300 by 300, or 300 divided by 300, it's 1. 0 divided by 300 is going to be 0. So we need this, either we flip this curve or we do 1.0 minus this. I think so. Or not. Hold on a second. Yeah, we're getting close to the object, so we got to do this. Which means this will interpolate from 0 to 1. And now we have the crossfade that we can work with. So we have the beacon close. We're also going to have beacon far, which works in the same way. Its curve is interpolated by this number. So we need to get the crossfade to kick this one in, kick this one out. So I guess we're gonna have to do plus, or I guess subtract. Let's go 50 times beacon fade, beacon crossfade. It's right here, you idiot. All right. Beacon cross. Okay, you know what? This doesn't need to be variable declared out of scope, but this one does. And it's 0.0. Or I guess, yeah, I guess that's fine. Cool. Okay, so the closer we get, we need this one to actually come into play. So we're gonna do 50 minus 50 times beacon, beacon fade, and then for this one, we need to make it dissipate in the opposite direction. So we can do beacon crossfade minus 50. That seems incorrect. What's that function that flips a value? -1? Multiply -1? I don't remember. Or 1 minus. Something along those lines. Okay. I think this literally is the same thing. So, okay. This becomes 1 as we get closer. It should be. Let's print. One minus in shaders. Oh, okay. 1 minus beacon cross. 50. Okay. Let me just double check this. I know it's this way. Yeah, okay, so that doesn't do much. I guess it wouldn't, because we're not actually dialing into the correct frequency. 216. Okay. Interesting. Beacon crossfade. I think that's because the curve dips a little bit higher. Okay. Let's see here. So as we start going back, it's reducing. Huh. Okay. So, as we're getting closer, this becomes 1. So we know that much. So 1 times 50 when we're close is, we subtract 50, but 50 minus 50 gives us a 0, so we subtract nothing, so we hear this. Okay, and instead, here, we can say 1.0 minus beacon fade. So it's inverted times 50. So as we get closer, it becomes quieter. And cool. I think I still need to do something here. Distance to target. Let's print both. Oh, did we crash already? We did crash already. Oh, distance to target doesn't exist there. Okay. Mm-hmm. Uh, 146. Hmm. I was getting a shape project going. Pretty good. I didn't go on a walk today because it was kind of zero visibility, and I had to take a drive, pick up some stuff that kind of cut into my morning routine. But you know what? It's good. A break is well deserved, I think. Other than that, yeah, not too bad. The initial burst of motivation is being chewed through. However, you know how that goes. But I still see benefits to the the whole endeavor. Okay, so this is interesting. Hmm. One minus. That's the idea. Oh yeah, it might actually sound the same. Hold on. Subtract negative 50. Okay, let's see, we're close. So this is 1. This is 1. So 50 minus 50 is 0. So this is audible. Okay, here. Oh yeah, it is the same. Okay. I think it's just 50 minus 50 times the reversed value. Okay. Wish the best luck in the endeavor. Appreciate it. I gotta say, probably the biggest appeal to the morning walks is that I put on Audible and I listen to audiobooks. I try to squeeze in something useful in the walk than just, you know, kind of strolling through it or slogging through it. Okay. So the beacon is still causing the needle to jump. So before we address the whole crossfading, let me double check that first. What do we got? I need to detect if we are honed in on a proper beacon. So targeted beacon, if it's not null. So we do this. If target beacon target beacon is not null, then we are currently honed in on a proper signal. So then it's gonna do this. I think we can go slightly more, well, insane with that value, because it also gets interpolated, smoothly transitioned, so that's something that we need to compensate for. Okay, so 333, nice. Nice. I mean, it works. See, the problem is that technically us looking up and down also causes the effect to be diminished. Hmm. Why don't I do this? If target beacon is not null, we're gonna do the print here so we don't have all these other prints. And let's also just output the decimal values for near and far. I think -50 might be just a bit too much. You're getting the global rotation of the camera, or the forward basis, which is -Z. Alrighty. 240. Hey. Okay, so it's interesting. Oh, that's curious. Which, okay, that kind of makes sense. If we're looking away. Oh, there we go. Unit size between 0 and 1. Yeah. That works. I still have to do a bunch of math. Oh, okay. So we're starting to get there. Take the player's rotation instead of the camera rotation should eliminate the problem. Yeah, but technically, seems like this is a logical behavior. You know, look directly in the ground. There's nothing there. Hey. You know what? Let's not make it go all the way to 80. Let's make it go to something more realistic. Like, let's do -70. That leaves us plenty of room for the beacon to move the needle up a little bit. Okay. 240. Nice. Cool. Logically, yes. Maximum efficiency when looking down, but we're gonna ignore that fact because I don't want players to go, am I going in the right direction? think I might want to raise just the base volume of these things. Let's go +5. Whoops. Yeah, depending on the antenna design. To begin tracking, insert directly into colon. 605. Oh, 0. 5. I mean, right now it's already 200 units. Just add the dig mechanic. Oh, yes. It's not like we learned anything from Subnautica. They added the dig mechanic and they regretted it for the rest of their development cycle. They stripped it out at some point. The whole terraforming thing was just a nightmare. Okay, so we're at 182. And now we're at 200. I might actually increase it to 400 meters. Nice. We could even add a light on the the radio ping itself, so you can correlate the ping with the light. Nice. Okay. Say that's pretty damn good. Oh, jeez. So much material compiling. Oh, I think Cole actually switched the internal sound. Love it. It's gonna need some sounds. All right. The placeholder note. Oh wait, what the hell did it say? Hold on a sec. Oh yeah. There's another one. Yeah, the shader works on all the monitors, thankfully. We get our butts over to the radio relay station. Alright, here's an unintended mechanic. Just place things right out of the inventory. I'm gonna see if I can add some sort of like a turning on effect. But I think, yeah, this should work. God damn, this is awesome. Oh yeah, that's right. He's got some creepy sounds that will turn on. There we go. We're gonna put some additional props here with some radio speakers and analytical equipment, because the player is supposed to control this as a part of the game objective. Man, that's a screenshot-worthy thing. I like that. Nice composition. Cool. All right. Is there anything that I can take off the list, off of the to-do list? That static noise is not pleasant. It's not supposed to be. Okay. What can we do here? Let me take a look at the list. Actually, I am out of time. I can't believe we actually got this into place. Still walking monsters. Yup. Gotta do that. Okay. Program radio locator. Done. Add radio beacon into rooms. Technically done, but I still have to actually, do that for each room. Allow combining map, compass, and GPS so that you can save space in the interface. We have the three components: the GPS locator and the map. So if we do, technically right now the map already comes with the GPS locator, and you can kind of get your current coordinates and then find it on the map and then mark it. But I wanted to make it so that these actually start out as two separate objects until you find a crafting bench where you can combine them together into one. So you'd still have the radio locator. Oh, no, that's not it. Coordinate device. And then compass. Right, so these things they exist as separate objects. There we go. Of course it doesn't work. Now we got this thing. Jiggly bitch. There we go. And this one basically kind of shows you where north is, except... yeah, it does. Now, technically, that's spinning in the wrong direction. Yes. Oh. Yeah. If we keep going this way, we're gonna reach the church. Or something. No, we gotta go this way now. North is just up. Also, hey, there it is. Beautiful. Yeah, I'm gonna have to fix that. The compass is going backwards. Yeah, we could do that a quick and easy fix. Capacity needle rotation equals lerp angle. North. And then it uses global rotation. Interesting. Negative global rotation? Yeah. That's more like it. All right, so that's done. Add compass to map, combining map. That's all fine and dandy. Allow simple crafting from player inventory without crafting bench. That's going to be an important one for very basic survival tools like flashlights with only a few shots, flashbangs with only a couple of flashes in them, enemy that is attracted to electrical activity, dynamo machine flashlight, batteries explode if overcharged. I need animated textures. I think I actually have to look towards film and look for like film something. Film texture sets and whatnot in order to get the animated explosions in place. Because I have not been able to find any game assets or game textures. It's like stills. I found plenty of stills, but I want something a little bit more animated. Cool. So let's wrap it up here. I think that's good enough. Not bad. We've implemented the radio beacon. That works. We can move on to greener pastures. Cool. All right. Thanks everybody for watching. Appreciate the company. And we'll continue next time whenever we continue. Cool beans. Who knows? Maybe even... Do I have time today? Nah, it's gonna be like 9 o'clock. Maybe. If I'm like super motivated, I'll dedicate the last hour towards something. The fried chicken man didn't turn out too well, so maybe we'll take a look at something anime related.